Here we want to find the area in between these two graphs. First, we're asked to find that point of intersection B. Obviously, A is at the origin, but where is B at? In order to find this point of intersection, we need to solve the system for y equals 1/2 x and x equals y squared. So what I'm going to do is take this first equation and double it, so we'll have 2y is equal to x, and then I can substitute for x, so that 2y is equal to y squared. It's quadratic, so I'm going to get equals 0. Subtract 2y from that, and factor it. So y times y minus 2, and obviously I get that y is equal to 0, or y is equal to 2. Well, obviously the 0 is happening at point A, that's when the y coordinate is 0. So for B, that's going to have a y coordinate of 2. But what's the x coordinate? Well, since B is on both curves, I could plug it into any of these equations, and that's the y coordinate. So 2 is equal to 1/2 of x, which means that x has to be 4. So that's talking about the point 4, 2. Next, we're asked to complete the representative rectangle. And I notice that the representative rectangle this time is oriented horizontally, which means that our height is going to be delta y because it's going in that y direction. And the base, the longer way, is going to be a horizontal distance that we're going to want in terms of y. So that distance is the difference between two x values, with the first x value being the one that's further to the right. In this case, that's the line y equals 1/2 x. In terms of y, that would mean that x is 2y. Then for the second curve, the one that's further to the left, that's on the parabola, and it says that x is y squared. So this would be the base of our rectangle, 2y minus y squared. That's super helpful for us now that we want to find the exact area, because our area is going to be a definite integral, where the base is 2y minus y squared. Our height is delta y, that turns into dy. And our limits of integration are going to go from A up to B in the y direction. Of course, at A, that was at the origin, 0, 0, and B, the y coordinate is 2. So now we have a definite integral that we need to evaluate. To do that, we're going to integrate 2y minus y squared, which the integral of 2y is y squared, and the integral of y squared is 1/3 y to the third. We'll evaluate from 0 up to 2. Plugging in 2 first, I'll have 4 minus 2 to the third is 8 over 3. And subtract from that 0 squared minus 1/3 of 0 cubed. So real quickly, 4 minus 8/3, well, 4 is 12/3, minus 8/3 leaves me with an area of 4/3.